familiar sight, the star-studded night sky. These millions of stars in the night sky are but a tiny part of what is known as the universe, whose size and limits are unknown. Our Earth, too, is a member of this universe. The universe comprises billions of stars, and clusters of these stars are known as galaxies. Scientists estimate that there are 10 billion such galaxies in the universe. Like a tiny grain of sand on a vast sandy beach, the Earth is located on the outer fringes of a galaxy that has over 100,000 million stars and is known as the Milky Way system. This galaxy resembles a giant Catherine wheel that is slowly spinning on its axis. This is the planet Earth, our home. A tiny globe spinning in the vastness of space. Pictures taken from satellites clearly show the Earth to be spherical in shape. But it is not perfectly round. It has a slightly greater diameter at the equator than between the poles. The brightest object in our solar system is the Sun. It is the center of our solar system. The solar system is a community of bodies which include asteroids, comets, and the 9 known planets. All these bodies constantly revolve around the Sun, the only star in our solar system. The planets and their moons do not radiate any light of their own, but shine by the light they reflect from the Sun. The Sun contains 99% of the mass of the entire solar system, which is mostly empty space. It is the massive gravitational pull of the Sun that guides the planets and the other bodies around itself. Compared to the Sun, the Earth is a mere dwarf, which can be accommodated 1.3 million times in the Sun's volume. This tiny section of the Sun's surface will give us an idea of its size in comparison with the Earth and the other known planets, which are Mercury, the smallest of the planets and the one nearest to the Sun; Venus, surrounded by impenetrable clouds; the Earth, our own blue planet; Mars, the red planet; Jupiter, the largest and with its gaseous layers, the heaviest; Saturn, recognizable by its encircling rings; Uranus; Neptune, discovered in the middle of the 19th century; and lastly, Pluto, the farthest from the Sun, with a temperature of minus 230 degrees Celsius, the coldest of them all. In addition to this, hundreds of thousands of rocky or metal objects called asteroids also revolve around the Sun, where they form an asteroid belt between the planets Mars and Jupiter. The asteroids, which are irregularly shaped, are usually less than a kilometer in diameter. The origin of the universe has always been a puzzle. Astronomers now favor the Big Bang theory, according to which the universe began some 15 billion years ago with a colossal explosion. At the time of the Big Bang, all the material in the universe was condensed into a superatom. The explosion ripped it apart and scattered dust and gases in every direction. Some 4.5 billion years ago, the spinning cloud of dust and gas contracted to form a star, that is, the Sun, and a family of 9 planets. What finally emerged was the highly ordered structure of our solar system. The size of the solar system is immense, and it is only by analogy that we can begin to appreciate the staggering distances. If we were to journey from the Sun to the outermost planet, Pluto, at a speed of say 1,000 kilometers an hour, it would take us over 600 years to reach our destination. According to the Big Bang theory, the newly born Earth, which is an accumulation of debris, heated up as its interior compacted due to force of gravity and heat from radioactive elements within it. As the heat increased, the Earth's rocky materials melted and began to separate. The lighter material floated upwards and cooled into a thin layer of partially melted rock to form the crust. Heavier elements like iron and nickel sank towards the Earth's center to form a core of iron-rich matter. While the Earth's structure was developing, gases were released from the interior. These gases also contained water that had been locked up in the minerals. These gases mixed together, cooled, and condensed into clouds that covered the entire planet. The water vapor in this atmosphere cooled and condensed and fell as heavy rainfall, filling up the basins in the Earth's crust, thus forming a primitive ocean that covered most of the Earth's surface. More than 3.5 billion years ago, the blue-green algae had appeared in the oceans, and it had the ability to use the energy from sunlight in a process known as photosynthesis. It used this energy to convert carbon dioxide from the seawater to carbon for food. Oxygen was released as a byproduct. By about 2 billion years ago, the oxygen expelled by the primitive organisms began to accumulate in the atmosphere, where it replaced carbon dioxide as the most abundant gas. Some of this oxygen was converted into ozone, which forms a layer in the atmosphere around the Earth. The layer of ozone screened the Earth from the harmful ultraviolet radiations of the Sun. This made the surface waters of the Earth safe for the emergence of more sophisticated life forms. The Earth constantly revolves around the Sun in a path called an orbit. The orbit of the Earth around the Sun is called a revolution. And while the Earth revolves around the Sun, it also spins on its axis like a top. This movement of the Earth around its axis is called rotation. The Earth's axis is an imaginary line running from pole to pole through the center of the planet. This axis of rotation is not perpendicular to the Earth's orbital plane, but is tilted at 23.5 degrees from the perpendicular. The Earth rotates at a speed of over 800 kilometers an hour, and while doing so, it also hurtles through space at a speed of over 40,000 kilometers an hour as it goes around the sun. These are incredible speeds. So how is it that we do not feel this motion? In fact, if we look around us, we will notice that everything around us is quite still. The reason we do not feel this motion is because the Earth's motion is completely steady. And while we are moving, everything around us too is moving at the same speed. This is the reason why everything around us looks still. It is like traveling in a train or a bus. It is only when we look outside and see things whiz past us that we realize that we are moving. The Earth always spins the same way, turning eastwards all the time. If we look down the North Pole, we would notice that the Earth turns in an anti-clockwise direction. It is because of this easterly rotation that we see the sun coming up in the east every day and going down in the west. One rotation, a complete turn, takes approximately 24 hours, causing periods of light and darkness we call day and night. As the Earth orbits the sun, the one half facing the sun is lit by it, and this gives us daylight. The part of the Earth facing away from the sun is in darkness, and it is the night side. As it journeys through space, our tiny planet has a constant companion, the moon. Other planets too have moons whirling around them, but the Earth's moon is quite large compared to the Earth. The moon is the brightest object in the night sky. But what causes it to change its shape? Why does it wax and wane? The moon has no light of its own, but reflects the light of the sun. The moon's phases are simply what we on Earth can see of this reflected sunlight at different times during its orbit around the Earth. Let us see how this works. When the moon lies between the Earth and the sun, no sunlight falls on the side of the moon facing the Earth. It is dark and invisible. It is called the new moon. As the moon proceeds along its orbit of the Earth, a growing or waxing crescent of reflected sunlight illuminates its eastern edge. At the first quarter, just a week after the new moon, half the moon's illuminated hemisphere is visible from the Earth. This portion waxes or grows until the moon's face is fully illuminated. The moon now begins to wane, going through its phases in reverse. The moon takes altogether 29 and a half days to go from one full moon to the next. This 29 and a half day cycle is called a lunar month. By the end of the lunar month, the moon is back in its original position relative to the earth and the sun. As the planets and their satellites orbit the sun, they cast cone-shaped shadows on each other. When one body casts its shadow on another, the event is called an eclipse. Let us see how this comes about. The moon revolves around the earth, and both these bodies revolve around the sun. As often as 3 times in a year, always at the time of full moon, the moon and the sun line up with the earth between them. The moon moves briefly through all or part of the earth's shadow, which is large enough to cover the moon. This is known as a lunar eclipse and can be seen from the earth anywhere where the moon has risen. Two to 5 times a year, the earth and the sun line up with the moon between them. And for a while, the moon's shadow falls on the earth, causing an eclipse of the sun. A total eclipse of the sun is seen as total only along a narrow strip where the moon's deep shadow, called the umbra, falls. The lighter shadow around the darker umbra is known as the penumbra. Viewed from the earth, this is what a solar eclipse looks like. In ancient times and even today, many people find eclipses frightening. But eclipses are nothing but the regular and predictable events in the workings of our solar system. The Earth's orbit around the sun is not perfectly round, but elliptical or oval. It is because of this, the Earth is closer to the sun sometimes than others. Because the Earth is tilted at an angle, periods of daylight and darkness and the angle of the sun's rays falling on the Earth vary at different latitudes throughout the year. Seasonal changes are due in part because of this tilt. In the summer, that is around June, the northern half of the Earth is tilted towards the sun, giving it summer, while the south has winter. Yet, when the Earth travels round to the far side of the sun, it is the south that is tilted towards the sun, and the seasons reverse. The northern hemisphere has winter, and the southern hemisphere has summer. sun is not only the center of our solar system, but our very existence. The heat and light from the sun are the reasons why life exists on Earth. The temperature on the sun's surface is about 6,000 degrees Celsius. Entirely composed of hydrogen, it is a vast furnace at whose center, every second, over 4 million tons of hydrogen is fused. The hydrogen nuclei fuse to form helium and release tremendous amounts of energy in the process. Formed from the dust of ancient stars, our planet is unique. For based on information available at present, life does not seem to exist on any other celestial body except the Earth. This has been possible due to a number of factors. The Earth has water in all the three forms: liquid, solid, and as gas. It has a breathable atmosphere of oxygen. It has the right temperature for life to exist. The thin blanket of its atmosphere screens off most of the harmful radiations of the sun. This sphere of rock, the planet Earth on which we live, is white hot and molten beneath the crust. Volcanoes still spew molten rock onto its surface. "30 kilometers above its surface, the air is too thin and cold for survival. Yet, between its surface and the vacuum of space is a fragile miracle, the biosphere, the zone of life. Here, life forms, however diverse, are all intricately linked together in an eternal dance of life."